Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So this is part number 3, Sidesway frame analysis. Okay, I have done two parts. Part number 1, part number 1, I have discussed about table number 1. In part 2, my previous video, I have explained how to assume FEM for member AB and calculate FEM for member BC and CD, okay, using ratio. Okay, now we will move to table number 2, Sidesway frame. We based on this frame. The frame is tend to move to right direction, R prime. So this is actually based on this Sidesway frame. And the FEM used in this table, the calculation of the FEM I have shown in the previous video. Okay, so now this is actually table number 2. So this is table number 2. As usual, table number 2, we calculate, we distribute moment using joint moment. Joint moment we distribute by calculate the joint moment with the distribution factor for each member n, and then we carry over the value. We repeat the process until the last distribution reaches 0 value and we stop the process. So we have to total the moment in the table, start from FEM until the last distribution, and the total value, the total moment, we label as M prime. M prime is the n moment or internal moment in table number 2. There are 6 value, represent 6 n moment from AB, BA, BC, CB, CD and DC. Okay, next step after this, we will use this n moment value to calculate R prime value. Because in calculating the final n moment, we have to have R value, which we get from table number 1, and we need to have R prime value, which we get from table number 2. R and R prime is actually the shear equation. The shear equation for two type of frame. Type number 1 is no Sidesway frame, and type number 2 is Sidesway frame. Okay, so using this n moment, we will sketch the free body diagram for each members separately. Okay, and we will put all the internal forces. So we draw it separately like this. Okay, so this ABC has UDL. No, it has no UDL. It is only have moment. Sorry. Okay, moment at joint B. Okay. This is basically refers to this. So what we have is actually the n moment, all n moment. So we get negative 87 here, negative 87, and negative 73. So this is 87.025 and 73.99. And then we have moment positive 73.99 and also positive 36.984. And then we have negative value, negative, it is 36.984 and negative 29.134. Okay, that is the n moment. So beside this, we have to put also the vertical and horizontal forces at each end. So at A, we have V1 and H1 like this. So balance with this V1 and H in opposite direction, H1. And for column CD, we will have V2 as well as H2 balanced with this H2 and V2. And then for member BC, we have to balance back V1. So this is V1, this is V2, this is V2, V1, V1 and V2. V1 and V2 like this, V1 and V2. So because from origin from not original, this is diagram D Sidesway frame. So from this, we know that we want to calculate R prime value. So due to that, we have to write the equation in order to calculate R prime value. So the equation is called as shear equation. The equation is called as shear equation. Shear equation means we have to include all horizontal forces, including this dx and this ax. All will have to label as prime. So from this, we can write the shear equation, which is total fx is equal to 0. So we get ax prime minus dx prime plus r prime. This is equal to 0. So we actually, the r prime is equal to minus ax prime plus dx prime. Okay, negative ax plus dx prime. So this is actually the equation that we will use to calculate r prime. So there are two unknown here. It is ax prime as well as dx prime. So that is why we have to have this diagram. So to calculate, okay, the first thing to do is we have to calculate this first. This one first, because from this we will get Vy value, V1, and this V1 is actually equivalent to this V1, okay, and after that we will get H1, and H1 is actually ax prime, okay, this is all we label as prime because this is table number 2, okay. So to calculate, so this is step number 2 and step number 3. Okay, when we calculate, do step number 1, we calculate V1. V1 is actually equivalent to AY. So this is AY. This is AY prime. Okay. So step number 1, so we calculate member BC. We take moment at C is equal to 0. Moment at C is equal to 0. So we get 73.99. We get 73.99 plus 36984. 36.9984. 36.984. We plus what is the distance? It is 6 meter. 6 meter. It is plus 6V1 is equal to 0. So we get V1 is equal to 73.99 plus 36.984. We divide by 6. We divide by 6. 6 divide by 6. So we get V1 equal to negative. It is positive. is positive, 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 negative 18.5 kilonewton. Negative 18.5 kilonewton. So we move to step number 2. In step number 2, we analyze member AB. So in member AB, we have to take moment at B is equal to 0. So it is negative 87.025 minus 73.99. 3.99. So V1 is minus 18.5 times the distance is 2.65 from the triangular. It is 2.65. And we minus another one, minus 3 H1. So from this we will get H1. H1 is negative 87.025 minus 73.99 minus 18.5 times 2.65. Okay, so we get negative. H1 is negative 70 kilonewton. And this H1 is equal to AX prime. It's all prime. Okay, this is negative 70 equal to AX. So we want another one, which is H2 prime. So we move to number 3. Step number 3 here. So in step number 3, we so it is negative 30 negative 36.984 minus 29.134 plus 7.5 H2. So this is equal to 0. It is negative plus. Okay, so H2 we get 36.984 divided by 7.5. It is 8.816 kilonewton. So this is H2, or this is actually dx prime. So we want to calculate the r prime value. R prime is equal to negative ax prime minus plus dx prime. So negative 70, it is negative 70, so negative positive 70. Positive 70 we plus with 8.816, so we get 78.816 kilonewton. 78.816 kilonewton. Okay, so actually this is the answer. It is 78 for the R value. 78 is the R value. 78.8 R value. For dx or H2 prime, it is 8.816. 8.816. This is 8.816. And for AX, we get 70. It is negative 70. We get negative 70. Means the answer is correct. So for the correction factor, okay, final end moment is MF is equal to M naught plus R divided by R prime times with M prime. So we get M naught plus, okay, this one is 78.816 the R value from previous from the first part of analysis, the R prime is, okay, it is 19.545, 19. It is 19. Is 19. Let me check. Okay, it is 19. 19.523. Okay, so negative 0.5. 19.545. 19.545. 19. So it is 19. 545. 545. So this is M prime. So this is M naught plus 19.545 divided by 78.816. We get 0.248 M prime. So this is actually the final equation which we derive from the principle of superposition. From the principle of superposition. So it is 0.248 here. 0.248, we get 0.248. So once we have this, so we just need to substitute M naught and M prime value. So there are 6 positions from AB, BA, BC, CD, DC. So we will get the final end moment as this. Okay. So that's all about the Sidesway frame analysis. This is an example where we analyze frame subjected to moment, subjected to joint moment at B. There is no FEM, but external loading, the external loading given is joint moment, so we distribute joint moment for table number 1, and for table number 2 we calculate as usual from the geometry of the frame. We assume FEM, and then we find the FEM for BC and CD, and then we put into the table. We find M prime, and finally we calculate R and R prime to have the correction factor and the final equation, which from the equation we can get the final end moment. Final moment is M final is equal to M naught from table 1 plus 0.248 is the correction factor time with M prime, and M prime is the end moment from table number 2. Okay, so before we end this, so let's draw the bending moment diagram from the value that we get here. Okay, from the value that we get here, so we have AB, positive. We have ABBA, which is positive, and then we have BC, and it is also positive. It's also positive, positive, and then we have negative for member CD. For member CD, we get negative. So for the bending moment diagram, we just need to follow the arrow. Means that this is the point. Okay, start from 0, end at 0. So this one, you just need to draw like this, and then we get outside is positive, this is negative value. Okay, for member BC, based on the arrow, the position is this and this. Start from 0, end at 0. So there is no UDL or point load, so we just need to join this. Okay, so this one is positive, this is negative. Okay, for member CD, so from the arrow, this is the position, this is the position. Okay, 0, 0. Okay, then we just need to join this. We need to join this. So the value is negative and positive. And the value is actually the value that we get from this 14.2, 53.2, 14.2. So this is 14.2. This is 14.2, 53.2. It is 96.7, 96.8, 96.8, 96.8. Then 22.8, 22.8. This is 22.8. This one also 22.8. And then the last value is 13 or 14, 14. So this is for 14. It's 14. And for member for join B, so this value we plus with this value, so we should get 150, 53.2 plus 96.8. So this is actually equal to 150 join moment at B as given in the question. Okay, so that's all how we draw the bending moment diagram for this question. Okay, so inshallah we will meet again in the next video. Thank you and assalamualaikum warahmatullahi wabarakatuh.